In this unit, we will discuss state reduction and assignment in this class. Okay. Let me know about what is state reduction. Okay. State reduction in the sense, okay, it may be the present state or it may be the next state, right? Okay. In diagram wise, if you look at the statements, we will represent the state in circle shape. Okay. If it is the state 0 0, okay, this is the state 0 0. Okay. Before applying any input, okay, that state we are calling as present state. Okay. After processing, okay, after applying the input, okay, it will generate some other state. Okay. In that case, we will say that state is next state. Okay. um, these are all the things we have to know, what is present state and next state. Okay. um, if we have four state, okay, if I have four state, 2 bits means I will have four state. Okay. 0 0 0 1 1 0 and 1 1. Okay. These are all the state I will have. Okay. Sometimes this act as a present state and it may act as next state. Okay. Okay. In which, okay, the state reduction is in which we're going to reduce, okay, total number of state. Suppose in this I'm having the four state, okay, in which I'm going to reduce into three state or two state and one state. Okay. The how long we reduce the state, okay, that state will leads to the reduction of number of flip-flops. Okay. In see, this is the flip-flop, right? This is the flip-flop. Okay. This will holds the value in it. Okay. Value in it. This input which is passing to the flip-flop is called as next state. Okay. And the flip-flop produce the thing is present state. Okay. In combinational circuit, the combinational circuits, any memory element which is passed the one of the input to the combinational circuit, then that we are calling as present state, because the out of the state is coming from us present state. Okay. After processing something, it will generate the combinational circuits generate the next state. That next state only we are passing to the flip flop. Okay. um, in this sense, the next state or the present state, okay, the next state and present state, okay, these are all the things which are processing into the flip flop. Okay. If the state is maybe in a next state or present state, the number of state which processing is reduced, okay, then the flip flop also, okay, which going to handle in the combination circuit or in the sequential circuit will be reduced. Okay. By reducing the number of states, by reducing the number of states, okay, the flip flop will be reduced. Okay. For that purpose only, we going to reduce the number of states. Okay. Just have an idea. Okay. When we try to reduce the state, okay, the flip flop also be get reduced. Okay. Suppose if I need 4 flip flop, okay, for an ordinary processing. Okay. In this, for me, 4 flip flop is not available. Okay. In this case, how can I deal this sequential circuit? Okay, in this condition, I can reduce the number of states of the processing. Okay, if I reduce the number of states of the processing, okay, obviously the flip-flop may reduce. Okay, for me, I'm having only the two flip-flop. According to my flip-flops, I can reduce the number of states. If a number of states is reduced means, obviously the flip-flop also get reduced, so that I can make use of my available flip-flop for the sequential circuit. Okay, according to the requirements of the designer, okay, can use the or can use the flip flop to design the sequential circuit or can make the sequential circuit. Okay, with this we're going to discuss on how to reduce the number of states. Okay, just for example, okay, these are all the inputs. Okay, these are all the inputs that we are handling. Okay, the inputs is nothing but, okay, the input is nothing but the input of the combinational circuit. Okay, through the input of the combinational circuit, okay, we going to decide the, okay, next state for the flip flop, next state for the flip flop. Okay, next state for the flip flop, in which we going to, by processing the input to the flip flop, sorry, combination circuit, the next state will be produced. That state only I'm going to reduce. That state only I'm going to reduce. If I send reduced state into the flip flop, obviously the reduced present state may occur. Okay, in this sense, with this input, okay, with this input, okay, I'm going to reduce the next state. I'm going to handle the next state of the flip flop. Okay, so I have taken the inputs. Okay, this processing of inputs, okay, before reducing the number of states, okay, just I have taken the inputs. Okay, for this inputs, just I have designed the state diagram. This is the input. Okay, these are all the input states. That is, in beginning, these are all the states available for me, that is given in the diagrammatic representation. Okay, after applying the reduction technique, after applying the technique, okay, my state will be reduced, my state will be reduced. Okay, this is the concept. Okay, by applying the state, by applying the input, okay, first I'm going to generate the state representation first. Okay, first by applying the input, I'm going to generate the state. Okay, that is next state. After producing the next state, I'm going to apply the reduction technique. After the state is reduced, then it will, the reduced state will be applied to the flip flop. Okay, the reduced state applied to the next state of the flip flop. The flip flop obviously produce the reduced present state. Okay, with this concept, okay, with this concept, first, with the help of input, I have, just I'm dealing my state. Okay, first I'm dealing my state in the sense I'm having in terms of diagrammatic representation. For input, how the state are constructed, first, this is the general state representation. Okay, general state representation, just look on here. First one is input 0, right? First, this initial state is A. First, the initial state is A. Okay, the first, the processing state start with A. If I apply 0 to the A, okay, I will get the output is 0 and next state is A. Okay, yes, generally I'm having the A state. Initially I'm having the A state in which I'm applying the input 0, then I'm getting the output 0 and I'm getting the status A. So I'm putting here a self state, right? Next to my status A, in which I'm going to apply the input 1. Okay. After applying input 1 to the state A, it will produce the output 0 and produce the next state B. Okay. Yes, for this A, for this is the state I have received recently. In this state I'm applying the input 1. After applying 1, I will get the next output is 0. I will getting the output is 0. The next state I have attained is B. Okay. Next thing, now I am in current state B, in which I am applying the input 0. Okay, then I will get the output 0 and also I am producing the next state C. Okay, my current status B, in which I am applying the input 0, I am getting the output 0 and my resultant state is C. C, in which C, okay, in which C I'm applying the input 1. Okay, then I'm getting the output 0. Okay, then next state will be the D. Output is 0, next status D. Okay, this is my current state C. Okay, in which I'm applying the input 1. For that I'm getting the output 0. Okay, my next state is D. Okay, next for D I'm applying the 0. My next state will be 0. So next output will be 0. Next state is E. 0, 0, E. I'm applying the input 0. For that output is 0. The next state will be the E. Okay, for E I'm applying 1. My output state will be 1 and the next state is F. For E I'm applying the input 1. Okay, my next state will, sorry, output will be 1. The next state is F. Okay. Likewise, we have to proceed all those things. Okay, at last we'll look at G. Okay, G, in this G I'm applying the input 0. Okay, and output will be 0. Okay, at last I'm applying the G input 0 and output is 0. Okay, and then it reaching the next status A, reaching the next status A. So it G reaching the next state A. This is what the circuit representation, that is state circuit representation. This is initial thing we have taken the state representation, in which we going to apply the reduction technique. Okay, after applying the reduction technique, the state will be reduced and then we will get the reduced state. Okay, then this one will be applied to the flip-flop. Okay, according to the number of reduced state, flip-flop will be enabled. Okay, then it produce the reduced present state. Okay, okay, for applying the reduction technique, for applying the reduction technique, okay, just we have to modify the diagram into, we have to modify the diagram into table representation. Then only we can able to apply the reduction technique. Okay, reduction technique cannot be applied directly to the diagrammatic representation. Okay, the reduction technique should apply to the state format of table. Okay, okay. The diagram I have written in terms of table. Okay, diagram I have written in form of table. Okay, first look at how they have represented diagram in terms of table. Okay, First, look at what are all the state. It's mentioned in circle format. A, B, C, D, E, F, G. Okay, that thing I have to mention here as present state. A, B, C, D, E, F, G. Okay, then I need to check on the output and the output and the input, whether input output is present in this state diagram or not. Okay, in this link or in this link, two types of transition available. Okay, in this link any other value is present, that we have to check. Yes, if a value is present means that thing, that is considered as input. Okay, after slash, if any value is present means that will be considered as output. Okay, likewise we have to check on all the transition link. Okay, if you look on all the transition link, there are only two types of input is present. Okay, before slash, just look on all the transition, there will be a two value present. One is 0, another one is 1. Okay, other than 0 and 1, there is no values present. So input I'm considering as a 0 and 1. Okay, then I need to look on the output. Okay, output value after slash. Okay, after slash, whether there is a element is present or not, I need to check on. After slash is present, so in what representation it present, that I need to know. In all the output, okay, I'm seeing the two value, that is 0 and 1. Okay, that is 0 and 1. So output representation is I'm mentioning here as 0 and 1. Okay, here here I'm taking the input variable as x. Okay, then output variable is y. Okay, the output variable is y. Okay, for me output is not important. Okay, output is not important for me, the state only the important. Okay, yes, we can also look at output, but here the state is the mandatory. Output is not mandatory here, it is a secondary one. Okay, for me need to find out the next state. Yes, I need to mention the next state here. Okay, for this, if I apply input 0, what will be my next state? Okay, if I apply input x equal to 1, what will be the next state? Okay, that I have to look on the given diagram. Okay, if I apply 0 to the state A, what will be the next state? If I apply 0 to the A, what will be the next state? Next state is A. So mentioned here is A. Okay, then I need to look on, if I apply x equal to 1 to the present state, what will be my next state? Okay, first I'm looking on the state A. First I'm looking on the state A. Before applying any input, that state is acting as the present state. After applying the input, that state will act as the next state. Okay, for A, I need to look on A, the one input applied, another input is applied or not, I'm going to check. Yes, A has the input 1. After passing the 1 to the state A, okay, then the next state will be B. Okay, the next state will be B. So next state will be B. Okay, yes, one state is finished. Right, one status we have finished. Next we have to look on the B state. Okay, then we need to look on the B state. Now we need to look on the B state. For B, if I apply 0, okay, what will be in me result state? If I apply 1 to the state B, what will be the next state? Okay, first I will try to apply the 0 and check on what will be the state. Okay, for B, I'm applying the input 0, my next state is C. Okay, for 0, my next state is Z. Yes, I'm applying 1 to the B, my next state is D. Okay, for 1, for 1, my next state is D. Okay, for 0, my next state is C. For 1, the next state is D. Okay, next we will move on focusing the next state. Okay, C. Okay, if I apply input 0, what will be the next state? If I apply 1 to the state C, what will be the next state? Okay, that we need to check on. I am the state C. Okay, if I apply 0, if I apply 0, what will the 0 means what will be the state A? If I apply 1, if I apply 1, the next state will be D. For A, for 0, next state is A. For 1, the next state is D. Okay. For 0, the next state is A. For 1, the next state is D. Okay. Next, we will look at the next state D. Okay. If I apply 0 and 1, what will be the next state? I will look at. Okay, now I'm looking on D. If I apply 0 means, if I apply 0 means next state is E. Okay, if I apply 0 means next state is E. If I apply 1 means the next state will be F. 0 means E, 1 means F. 0 means E, 1 means F I'm getting. Right. Next, we will look at next state. The next state is E. Okay. Next state, I need to next state I need to check on. Okay, what will be the next state for the E? This is the E, right? I'm applying 0. Yes, I'm applying 0. Okay, the next state is A. For this one, I'm applying 1. Okay, then the next state will be F. Okay, my next state will be F. So AF. For E, the next state is AF. Okay. For E, the next state will be AF. Next, we will check on the state F. Okay. For applying 0 and A to the F state, what will be the next state we will look on? Okay. F means what will be the next state we have look on? Yes, this is the F. Okay. If I apply 0 means next state will be G. Okay. If I apply if I apply 1 means, okay, if I apply 1 means the next state will be F, self state. Okay, if I apply 0 means next state will be G. If I apply F 1 means next state is F. Okay, GF I'm getting as next state. So GF I have written here. Okay. Next, we'll look at the next state G. Next state is G. Then we'll check at what will be the next state for the input x equal to 0 and x equal to 1. G, okay. G, I'm applying the 0 input. Okay, for G, I'm applying the 0 input. My next state will be, A. My next state will be A. Okay. If I apply 1 for the G, then the next state will be F. Yes, 1 I'm applying here, the next state will be F. So for G, if I apply 0 and 1, my output state will be AF. Okay, that's what I've written here. My output state will be AF. Okay, this is the next state I have mentioned in table format from the state diagram. Okay, next we have to look on the what will be the output represent. This is not mandatory, but in the diagrammatic represent, each state has the output. Okay, that we have to specify. Okay, you want to use the variable y, you can use for it. Okay, or else you want to write output itself, just you write output itself. Okay, the notation is up to you. Usually we will have input as x, output as y. Okay, in previous analysis of sequential circuit and all, we have looked this variable only, but variable is up to the designer. Okay, we'll look at the how the output is represented. Okay, for the present state. Okay, the next state, what will be the output? If a present state A and a next state A, for the input 0, what will be the output? Okay, what we have to look at here, the input is input's present state is A and the next state also A. Okay, so present state is A, my next state also A, but so that I am having the self loop. Okay, next present state also A, the next state also A. Input I'm looking on, the input is 0. Okay, so 0 I need to look on. What will be the output? That I have to write from the given diagram, and then I need to mention here. This types of representation where it is available, I need to look on. Okay, yes, this types of representation is mentioned here. Okay, yes, A. Okay, this is the input 0. Okay, this is present state and also next state, the input is 0. Okay, my next state, the output is 0. The output is 0, so I'm writing here as output is 0. So that's 0 is mentioned here. Is it clear? Next I need to look on for the input 1. Okay, the present state is A, the present state is A, and for this x equal to 1, the next state is B. So the next state is B. This is present state, next state is B. The input is applied between present state, next state is 1. So applying the 1. Okay. By applying 1, okay, to the input state, that is present state A, the output state, the next state will be B. For that, what is the output? This types of representation we need to look on the diagram. Okay, in this representation we need to look on the diagram. For A and B, for A and B, okay, for A and B, there is a input 1. Okay, then in which what will be the output? The output is 0. Okay, for A and B, the link of 1, that is input, what will be the output? The output will be 0 is mentioned here. The output will be 0. That I have to write here. The output is 0. Okay, then I need to move on next state. Next state is B, in which I need to specify the what is the next state for the input x equal to 0. Okay, present state is B. Present state is B. Okay, the next state is C. Okay, the present state is B, next state is C. For the input x equal to 0, so the input x equal to 0, what will be the output? That I have to look on the diagrammatic representation. BC, where BC is present. I need to look on where BC. This is the B, this is the C. Yes, both are present like this. The input is 0. Then what will be my output? Output is 0. Okay, I have to mention here. Output is 0. Okay, for X, the output is 0. Next, I need to look on the same state for the input 1. Okay, the now present state is B, the next state is D. Okay, the input which is passed in between is 1. Okay, then what will be the output? Okay, that we need this type of representation. I need to look on the diagram. BD in between 1 should present. BD in between 1 should present. This is B, this is B, this is the D, in between 1 should present. This is the input, and what will be the output? Okay, the 0 is the output. Okay, then I have to mention, okay, 0 is the output. Okay, is it clear? Is it clear? Okay, next we will move on the next state C. Okay, next we will move on the next state C. For this C, if I apply the input 0 means, okay, I will get the output 0. If I apply 1 means, then my output will be 1. Okay, for D, if I apply the input 0, then output will be 0. If apply 1 to the state D, my output will be 1. Okay. For E, my output 0, for the input x equal to 0. Okay. For the state, I will getting the output is 1, for the input x equal to 1. Okay. Next F, for F I'm getting the output is 0, for the input 0. For same state, I'm getting the output 1, for the input x equal to 0. Okay. Next state G, for G I will getting the output as 0, for x equal to 0, and I'm getting the 1 output for the input x equal to 1. Okay. This is out. Okay. This is how we have, okay, converted diagram into table format. Okay. Just we have converted the diagram into table format. Hereafter only I need to apply the reduction technique, because directly reduction technique will not apply to the diagram. Then the reduction technique only applied to the table state format. Okay. For that only I have just converted diagram representation into table representation. Okay. Now only I'm going to apply the reduction technique. Okay. Listen. Yes, I have the total number of states. Okay. How the reduction technique is applying here. Okay. Just look on here. Okay. The present next state and the output. Okay. Which one is similar, that I have to look on. Okay. This line is check out. This line, it is present again or not. Okay. Just check on this next state and output is present again or not. AB00, AB00 is present. AB00, no. This one is AB00, no. Likewise, AB00 is not present in the any of this state and output, right? Okay. Next, I'm looking this one. Now I'm looking this one. CD00. CD00 is present again or not, I'm checking. CD no. CD no. CD. Yes. This state also is not present again. Okay. Next I'm looking this state. AD00 is present or not. I'm looking on
Not present.
AD is present or not. AD, here no AD, here no AD, here also no AD, here also no AD, right? So AD is not present. Okay. Next I need to look on the next one. EF01. EF01 is present or not. This is EF, this is not EF, this is not EF, this is not EF. So this one also not present again. Just now I'm looking this state. AF is present again or not. This is not
Present
AF,
again.
this AF is present. And AF01 I need to look on. Full thing I need to look on. AF01. AF01 is present. AF01 is again present. Then GF is present or not, I'm checking on. Yes. Next line GF01 is not present. Okay, the repetition on the status, this one. Okay, AF01, AF01. This state is repeating again. So I need to eliminate one state. Okay. Okay, these things are repeating. Okay. Okay. For this one, I need to eliminate any one of the state. What I will eliminate? Last one I eliminate. Okay. Last one I eliminate. Okay. Because they both have the same processing, right? Why need to have same processing state repetition, right? So that I'm deleting this whole line. Okay. So I'm deleting the whole line. Yes, I have deleted the yes, I have deleted the whole line. Okay, I'm deleted the whole line, and then in which I have reduced the one state, right? Already I am having the 1 2 3 4 5 6 7 state. Now I have reduced into 6 state because this state I have eliminated. Okay, this state I have eliminated. After elimination, okay, um, what I will get is these are all the remaining state. Okay, see what are all my present state: A B C D E F. This is the actual state. Okay, before processing I'm saying this is a present state, but these are all this actual state. Okay, these are all the actual. In next state also, if I apply any input to this present state, or it may be 0 or 1. Okay, next state which will be produced for this is the same state as the present state. Maybe the ordering may be vary. For A, I will get B. For B, I will get D. But the resultant state will produced is coming from the present state only. Okay. Uh, Without this state, okay, with, I don't need to have extra state here. Okay, the all the present next state should come from the only the present state. Okay, or it may be C or it may be E, but it should come from the A B C D E F. Okay, other than this state, I won't have the next state, in which I am checking here whether I'm having all the state from this present state or not. A B, okay, this is present state. C D is the present state. A D is the which is available in the present state. EF also is available in the first present state. AF also available from the present state. GF, F is available in the present state, but G is not available in the present state. G should not come here. Okay, because I'm having the overall status only the sixth state. Okay, I'm having only six state: A, B, C, D, E, F. Okay, G I'm not having as the state. G is not having a G because I have eliminated already. Right? G should not come in the next state. I have to replace some other state with G. Okay. Now only I have said this. This E and G is equal each other. E processing and G processing are equal each other. So only I have eliminated the G. Okay. So indirectly I can mean that E is equal to G. Okay. Whatever I have the G in the next state, I should replace this with E. Okay. The G should not come here. For this, I should not eliminate G totally from the next state. If I eliminate means it will become 0. Okay. That I should not do. For this I need to have a replacement. Okay, for replacement what I will go for the statements, I need to check on the equivalence, G equivalent state. Okay, G equivalent state is E, so in that place I need to replace E. Okay, so after eliminating G, yes, I have written all the state: A, B, C, D, E, F. Okay, here in F position I have got the G as the next state. Now I have replaced G as E and then mentioned here. Okay. Now I'm checking on the next state. All the states which are arised from the only the given state. The given state is present state. A is available in present state. B, C, D, again E, F. Okay. All the states are available here is which is come from the present state only. Okay. Yes. In this, I have removed one state. The G state I have removed. Okay. From 7 state, I have reduced as 6 state. Okay. Next, we will look on. Okay. Here, I'm having the sixth state. Sixth state. Okay. I'm going to reduce this as 5. Okay. I'm going to reduce this as a 5. Before I had a 7 state, then I have reduced to 6 state. Now I'm having the 6 state, I'm going to reduce the 5 state. Okay, in which the same process to be follow here. Okay, A B 0 0, that should present again or not, I need to check on. Okay, A B 0 0, here A B 0 0 no, A B 0 0 no, A B 0 0 no. Okay, AB is not repeated here. Okay, CD, I need to check whether the CD is repeating or not. CD, whether CD is present? No, CD is also not repeating. AD 00 is present or not? I need to check on A. AD is not present. AD, AD is not present. Then I'm going to check on this one. EF. EF. This line I'm going to check on EF01. Whether in this EF01 is present, is in this present. Okay, in this line is present. This is repeating. Okay, next AF I'm checking on AF01 is next line AF01 is not present. So I have checked there is a repetition or not. Yes, I have seen the repetition. Okay, repetition for the state. Repetition for the state D and F. Okay, D and F, both the states are equal each other. So I'm deleting the F. So I'm totally deleting the F. Okay, there is only one processing should be available in the state. Okay, so I'm totally cancelling the F here. Okay, then I'm checking. Okay, now I'm checking all the next state are which is present from the present state. Okay, AB is available in present state. CD also available in present state. AD is available. A is available. F is available in the present state. No, F is not available in the present state. Okay, the F is not available in the present statement. Next state should not be as F. Okay, so that should be removed. Removed means I should not remove like empty. Okay, it should not be like empty. Okay, it should have some other state. So I will go for replacement. How the F is replacement, and this line EF, this line EF is equal each other, so only I cancelled. Okay, so that which means that I'm indirectly mentioning that F is equal to D. F is equal to D. This line only getting repeated, right? So I'm saying that D processing which is equal to the F processing. So I'm saying F equal to D. So whenever I get the next status F, I should go for the replacement of D. Right, this thing I have mentioned here. Okay, after reduction and after processing, this I have written here. What are my present state? A B C D E. A B C D E. Right, then AB I have written AB, then CD is written CD, AD is written AD, in which E is I have written E, and then F should not come here. F, instead of F I need to write the D state here. Is D I have written here. Okay, next A is I have written A, and then F should not come here. Instead of F, the D should come here. Okay, and then next state it holds all the state of present state. So before reduction I got the 6 state, and after that I'm getting the after reduction I'm getting the 5 state. Okay, just I have reduced 5 state into, sorry, 6 state into 5 state. Next, this is the 5 state. Okay, then I have to move on for reducing 5 state into 4 state, so that I'm checking this one. Okay, whether it getting repetition or not. AB00 is repeating or not. AB is repeating. Whole line should repeat. Okay, here AB is repeating, but here output 00, here it is a 01. So that I should not consider this as a repetition, because the whole line should be same like another state representation. AB00 means it also have the, sorry, this is AD, right? So definitely this will not be. So I thought that this is AB. Okay, but this is AD, right? So the AB is not repeating. So I'm taking this as a non-repetition state. Okay, next I'm looking on the CD. Okay, CD 00. CD is coming again. No, CD 00 is not coming. This is A. C is not coming again. So I'm going for next state. That is next state is AD 00. AD 00 is repeating. Yes, in this line repeating. AD is repeating. AD is repeating here. But the output state is 00. But here output state is 01. Okay, the whole line should repeat. Okay, here the whole thing is not repeating. Okay, whole thing is not repeating. AD 00 here AD 01. So this I will not consider as a repetition state. Okay, so this is not repetition state, this is also repetition state, this is also not a repetition state. Next I'm looking on ed is present next state again or not. Yes, the ed is not present, so this is I'm saying it not repetition state. Ad is again present or not, so ad also not present. Okay, if two processing state is equal, then only I can able to cancel one thing. Okay, if two-person is duplicating, okay, then they both doing the same process, then I will go with one person, right? I will not consider another person, because two-person are saying the same process, doing the same process. Okay, for that I will consider the only one process. The next process I will not consider at all. That concept only we are implementing for reducing the state. Okay, here here all the states are have own individuality. Okay, so I can't reduce the state here. I should not neglect delete any state here. Okay, from which I'm concluding that from 5 state I can't able to reduce the 4 state, because if anyone getting repetition, that time I will repeat, I will cancel. Okay, that time I will cancel, then I will say okay, I got the 4 state. Here there is no repetition. Without repetition, how can I cancel the state? How can I make the 5 state into 4 state? It is not possible, right? So with this I'm concluding that I have reduced all the state. Okay, from 7 state I have reduced the 5 state. Okay, from 7 state I have reduced in the 5 state. Okay, after reducing, just I need to uh, draw the reduced state diagram from the reduced state table. Okay, first I need to look on this present state. Okay, what are all the state A, B, C, D, E? Just I need to go with the circle representation A, B, C, D, E. Okay, then I need to go for the applying input x equal to 0, x equal to 1. If I apply x equal to 0, okay, my next state is A and output is 0. Okay, the next state is A and output is 0. Okay, A 0 I need to mention. Okay, if I apply 0, my next state is A. Okay, then output is 0. I'm applying 0 to the state A. My next state will be the A. Okay, for this output will be 0. Okay, this is the diagram for this one. Okay, next I'm applying 1 1. Okay, for the same state A. Okay, my output will be 0. Sorry, output will be 0 and the next state is B. Okay, then I'm applying 1. The next state will be B and output will be 0. Okay, yes, here they mention I'm applying 1. Okay, the next state is B, the output is 0. Okay, next let's look on the B state. For B, x equal to 0 means C state I'm getting. Okay, and output is 0. C 0 I need to get. Okay, for B, the next state is C. Next state is C. For the input 0, the next output is 0. Okay. Next, for the same state, we will apply 1. The next state will be D. Okay, the output will be 0. So, for B, if I apply 1 as a input, the next resultant I will get is D0. Okay, D0 I will look on. For applying 1 to the input B, my next state is D. The output is 0. Okay. Next C state we look on. For C, okay, the next state is 0 and output is, sorry, next state is A and the output is 0. A 0. This is C, this is C. Okay. For applying 0 is the input, the output state is A and output is 0 and output is 0. Okay. For same C, if I apply 1 means output will be 0. The next state is D. D0. Okay, if I apply 1 means next state will be D and the output will be 0. Okay, next. Next, we will look on the next state D. Okay, D, if I apply 0 means what will be next state and output E0. E0, look on this. If I apply 0 means E, output is 0. Okay, output is 0. Output is 0. 1 means if I apply 1 to the same state D, the output state is D and the that is next state is D and the output is 1. Okay, D1. Okay, if I apply 1, the output state is D. Okay, the output is 1. For looking E state, if I apply 0 means the next state will be A and output is 0. A0. Okay, for E I'm applying 0, then next state is A and output is 0. Okay, next we will look at the next one. One I need to apply. One apply means then output state will be D and output will be 1. Okay, D1. Okay, for E I'm applying 1 input. My output will be 1. The next state is D. Yes, according to this state table, I have drawn the state diagram. Right, and previously you look at the given diagram. This is my given diagram. Right, this is my given diagram. Okay, in which I have the 7 state. Okay, and then I have reduced the the 7 state into 5 state. Okay, in this diagrammatic representation, I have a 7 state 1, 2, 3, 4, 5, 6, 7, and after processing all those things, I have a reduced state 1, 2, 3, 4, 5. Right, this is the reduced state diagram. Okay, this is called as state reduction. This is called as state reduction. Okay, see, listen, for your university exam, if you ask state reductions means, okay, they will give you the diagram. Okay, this diagram will give or some other diagram will give. Okay, what we have to do is, if a diagram is given means what we have to do is, we have to apply the reduction technique. We have to apply the reduction technique and then produce the reduced diagram and produce the reduced diagram. Okay, you have to produce the reduced diagram. Okay, but reduction technique is not applicable directly to the diagram. Okay, for that you have to convert the given diagram into table format. Okay, in this table format only you have to apply the reduction technique. Okay, then you will get the reduced table. Okay, then from which reduced table you should draw the reduced diagram. Okay, the given diagram, it has the more number of states. Okay, after applying the reduction, okay, I will get the reduced number of states. Reduced number of states. Okay, these are all the supporting format. Table format, original table and reduced table. These are all the supporting table. Okay, because the reduction is applied only to the table. The main thing is, for us university exam, the diagram will be given, state diagram will be given. Okay, by doing all those things, you have to reduce the given diagram into reduced diagram. Okay, is it clear? My main agenda is this one. This diagram is my main agenda. This diagram only should get reduced. Okay, then I will getting the reduced number of state. Okay, suppose for your university exam, they have given state table. State table means they have given the table, state table. Okay, then you should make the reduced table. Okay, reduced table, it is very easy for us, because reduction table, reduction technique, we can directly apply to the table format. For us, the given diagram, okay, you should provide the solution in terms of diagram. Okay, if they given you the table format as a question, you have to provide the solution in terms of table format. This is the thing you have to look on. Okay, this processing will not given for you. Okay, for understanding, I have said that for this sequence we made the diagram. Okay, for university exam, the sequence and all will not given. For your understanding, you may ask how this diagram directly come through. Likewise, you may ask. Okay, the diagram is made for some processing. Okay, the each and every reduction table, or that is the given table, is made for some processing. Okay, it's not given just like that. But for you, you will look at the diagram only, but behind this scene, okay, there is a processing. Okay, just I have shown you the processing. This is the processing. For this processing only, the diagram is mentioned here. But in university exam, they will never look on the processing of any state. Okay, just they will given you the diagram. Just what is your thing is, you have to reduce that, and then you should mention as reduced diagram. Okay, is it clear? What you have to know is how to go the reduction, how to deal about the reduction. Okay, the same state has the same processing. Okay, that time you eliminate any one of the process. A, B has the same next state and output, and B also has the same next state and output. Okay, the A and B have the same processing of next state output. Why not to have both the state here, so that we will eliminate some state and will hold on any other state. You want to hold A means just you can go for A, or you want to hold B means just you can go for B. Any other state you want to hold on, just you hold on. Just for our problem solving, just I have eliminated the last state. I have used the before the last state. Just for you also, for your easy understanding reduction, just you try to delete the second state. Okay, if first state and second state on some other position, both are same processing. Okay, that is both are getting repeated, so you will eliminate the last one. Okay, then you go for having the first one as the uh, next processing. Is it clear? Do you have any doubt in this? Just I have a diagram in form, in form that this is called state diagram. Okay, after doing all those things, just I had a reduced state diagram. Okay, in which I have a 5 state. Before given diagram, I got a 7 state. From 7 state, this is 7 state constitute state diagram, from which I have designed, okay, reduced state diagram. Okay, next one is state assignment. Okay, next one is state assignment. Okay, uh, just I'm assigning the binary value to the state. Okay, this is called as state reduction, sorry, state assignment. Okay, state assignment is nothing but the binary values will be assigned to the state. Okay, that is called as state assignment, in which look on this these are all the state. Okay, this may have the any assignment. Okay, it may uh, have the assignment of binary, or this other state may get the gray code assignment, or it may be the one hot assignment. Okay, just I will go with this assignment, binary assignment. Just I will go with this binary assignment. Okay, wherever I look at the state A, which will be replaced by the term 000. Wherever I look the B state, I will replacement is 00. I will do the replacement as 001. C means my replacement will be 010. D means replacement will be 011. E means replacement is 100. Right. Uh, this one, we will look at, for example, we will look at this table. Okay. Okay, if suppose I have assignment A equal to 000, B equal to what will be the assignment, B equal to 001, B equal to 001. Okay, then C equal to 010, C equal to 010. Okay, then D equal to 011, D equal to 011, 011, E equal to 100, E equal to 100. Yes, look at here. Okay, wherever I locate the A, I need to replace with 000. B means I should replace with 001. C means I need to assign 010. D means I need to assign 011. E means I need to assign 100. Here also A means that replaced by 000. C means replaced by 010. A means 000. E means 100. A means 000. B means 001. D means 011, 011, 011, 011. Okay, here this table is looking like all the state in terms of zeros and ones, not in terms of variables. Okay, because I have assigned all the states in terms of zeros and ones. Zeros and ones made us binary assignment. Okay, we have three types of assignment. One is binary assignment, then another one is gray code assignment, another one is one hot assignment. Just I have made the first one so that I got all the state representation as binary representation. Okay, you want to assign gray code representation? Yes, go ahead. I am assigned the binary terms for all the states. Okay, so that it's look like. Okay, because it previously may it have A, previously it have the B, previously the third thing will be the what, previously the state representation will be C, right? So instead of C I have mentioned as 010. Okay, previously what mentioned is D. Okay, for D, I have substituted. D means I have substituted 011. D means I have substituted 011. Previously, next what state they have is E. E means what I have to substitute. E means 100. I have to substitute. So I have substituted 100. Here, what state previously is mentioned here is what mentioned AC, AEA, AC, AEA. AC, A, E, A. Okay, for A I have replaced 000. For C I have replaced 010. For A again I am replacing 00. For E, C is mentioned here 100, so I mentioned here. For A is 000. Okay, these are all the thing is D, right? The all the thing, the first one is B, remaining thing is D. Okay, the first one is B and remaining thing is D. The first one is B and the remaining things are D. B means what assignment I made. B means 001. So this is 001. Remaining things are D. For D representation, the representation is 011. So the remaining representation is 011, 011, 011, 011. Okay. The state will has the any assignment. Okay, it may be a binary, or it may be a gray code, or it may be a any other one hot assignment. Okay, then we are saying this concept as state assignment. Okay, state assignment. Okay, here I have assigned the binary values to the state. So this is the state representation of binary. Is it clear? Any doubt you have? See, this is not mandatory. Okay, how this diagram is came from. For this only I have taken this sequence of input. For this sequence of input, they made the state diagram. Okay, this one is processing is not important here. For your university exam, they will given you only the diagram. The processing behind this diagram will not given. Okay, for your understanding, just I have taken this processing. For this processing only, the diagram is made here. Just I have explained you. That's all. Okay, but in university exam they have given you this diagram. You have to convert into just reduced diagram. Okay, in between you can't apply the reduction technique directly. For that you have to first make the diagram into normal table representation. Then only you can apply the reduction technique. The reduction technique applied means then you will get the reduced table. Then my given is diagram. So my result also, the solution also in form of diagram. So the table will be, okay, the table will be in form of diagram. Finally, I can say that diagram is reduced diagram. My question is diagram. My solution also in terms of diagram. The reduction technique cannot applied directly to the diagram. For that purpose, I have made the diagram into table and then reduced table into diagram. Diagram to table conversion definitely you have to know. Okay, and table to diagram conversion you have to know. Okay, without diagram to table conversion knowing, and without knowing table to diagram conversion, definitely whatever you know the reduction technique is not worthless, it's not worthful. Okay, so you should know the conversion of table to diagram, diagram to table. Okay, this thing is mandatory. Okay, reduction, obviously you get to know that any state will repeating, any of the state you should remove that and we'll have only one state. Okay, this is the reduction technique. Okay, in which reduction state, okay, the state reduction you should know. The thing is how to convert diagram to table. Okay, then how to convert diagram to table to diagram, then how to apply the reduction technique. Okay, the three things you have to know for this concept state reduction. Okay, the next one is assignment. Okay, any state will be replaced by some other assignments. Okay, then the concept is called as state assignment. Okay, in this we have assigned the binary values to the corresponding state. So the state representation will look like the binary representation. But in behind this, the state is working on. Okay, the condition of state is working, but representation only differs. Before representation it is represented as A, B, C, D, but after substituting all those things, the representation it will be in the binary form. That's all. The processing of the working nature of the state is similar only. Just it just renamed as some other term. That's all. Okay, but behind the processing is same before applying the substitution, after applying the substitution.